The cosmos is full of whispers. Some are the ancient echoes of the Big Bang, stretching across billions of years to reach our sensitive radio dishes, while others are the frantic pulses of dying stars. But occasionally, we encounter a signal of movement that seems to defy the very grammar of the universe. When NASA's deep space eyes perceive something moving faster than physics supposedly allows, it is not just a headline. T is a profound challenge to our collective human ego. We have spent centuries constructing a magnificent edifice of laws. From Newton's predictable clockwork to Einstein's elegant curved spacetime, to find something that breaks those rules is to realize that we are still, in many ways, children playing with pebbles on the shore of a vast, uncharted ocean. To appreciate the gravity of a faster-than-light detection, we must first confront the absolute nature of the cosmic speed limit. Consider the photon. It is a particle of light, massless and tireless. In the vacuum of space, it travels at $c, or roughly 300,000 kilometers per second. Einstein showed us that as an object with mass accelerates toward this speed, its mass increases toward infinity. To push a single grain of sand to the speed of light would require all the energy in the universe, and even then you would only arrive at the threshold, never crossing it. Space and time are woven together in a four-dimensional fabric where light is the ultimate messenger. If information or matter were to travel faster than this, causality itself would begin to unravel. The effect could precede the cause. A star could explode before it ran out of fuel. A message could be received before it was sent. This is why physicists react to superluminal claims with such intense, disciplined skepticism. It is not that they are close-minded. It is that they are protecting the very foundation of logic. Yet, our telescopes often see things that appear to be sprinting past this barrier. We look at the hearts of distant, active galaxies' quasars powered by supermassive black holes and we see jets of plasma erupting into the void. When we measure their progress against the backdrop of distant stars, our calculations sometimes return impossible numbers. We see blobs of matter appearing to move at 4, 6, or even 20 times the speed of light. In the 1970s, when these observations first became common, there was a sense of panic and exhilaration. Had Einstein been wrong? Was the universe a lawless frontier? The answer, as it turns out, is a beautiful lesson in perspective. This is the phenomenon of superluminal motion, a geometric illusion born of the vast distances and high velocities of the deep cosmos. Imagine a jet of matter screaming toward Earth at 99% the speed of light, but at a very slight angle to our line of sight. As the jet moves, it is constantly emitting light. Because it is traveling nearly as fast as the light it emits, the light from the later positions of the jet arrives at our telescopes only a tiny fraction of a second after the light from its earlier positions. To us, looking on from millions of light years away, it looks as though the object has crossed a massive distance in almost no time at all. It is a cosmic sleight of hand. The physics is preserved, the speed limit is honored, and we are reminded that in a relativistic universe, what you see depends entirely on where you stand and how fast you are moving. But let us entertain a more provocative possibility. What if we found something that could not be explained away by geometry? What if NASA's latest data suggests a movement that truly bypasses the Einsteinian limit? To explore this, we must look at the loopholes in the fabric of space itself. General relativity tells us that while nothing can travel through space faster than light, space itself can expand, contract, or twist at any speed it likes. During the earliest moments of the Big Bang, in a period we call inflation, the universe expanded at a rate that dwarfs the speed of light. This didn't break any rules because no matter was moving through the vacuum. Rather, the vacuum itself was growing. If we are observing impossible movement today, we might be witnessing a natural manifestation of these loopholes. Perhaps we are seeing the signature of a wormhole, a bridge between two distant points in spacetime. If an object enters one end of such a bridge and emerges at the other, it hasn't outrun light in a race. It has simply taken a shortcut. To an outside observer, it would look as though the object traveled thousands of light years in an instant. This is the stuff of dreams and science fiction, but it is also the stuff of high-level mathematics. If such things exist in the wild, they would be the ultimate fast lanes of the cosmos, placed there by the strange topology of gravity. We must also consider the strange world of quantum mechanics, where the rules of the large-scale world seem to dissolve. We know of a phenomenon called quantum entanglement, which Einstein famously dismissed as spooky action at a distance. When two particles are entangled, a change to one is reflected in the other instantaneously, regardless of whether they are centimeters or light-years apart. While we believe this cannot be used to send information faster than light because the results are random, the connection itself is undeniably superluminal. If NASA has detected a macroscopic effect that mirrors this quantum behavior, we are standing on the edge of a revolution that would make the industrial age look like a footnote. Why does this matter to us? The inhabitants of this small, fragile world? It matters because we are a species of explorers. We have moved from the savannas to the poles, from the atmosphere to the moon, but the stars remain agonizingly distant. With our current technology, a journey to the nearest star system, Alpha Centauri, would take many human generations. We would be launching generation ships, where those who arrive at the destination are the great-grandchildren of those who left Earth. It is a daunting, perhaps impossible way to settle the galaxy. But if there is a way to move faster than physics allows, if we can learn to fold the map rather than crawling across it, then the entire Milky Way becomes our neighborhood. This is the promise of the anomaly. Every time a scientist sees something they don't understand, it is an invitation to learn a new language. When we saw the impossible orbit of Mercury, it led us to general relativity. When we saw the impossible behavior of light through a prism, it led us to quantum mechanics. These moments of confusion are the precursors to our greatest leaps in understanding. We should not fear the breaking of our laws, we should welcome it. It means the universe is bigger, stranger, and more full of potential than our most daring poets have ever imagined. As we sift through the data from our satellites and deep space probes, we must maintain a delicate balance. We must be skeptical, demanding rigorous proof and peer review. We must rule out the mundane, the sensor glitches, the orbital debris, the atmospheric interference. But we must also keep our sense of wonder intact. If we are too cynical, we might miss the signal that changes everything. We are a way for the cosmos to know itself, and the cosmos is under no obligation to be simple or to fit within the boxes we have built for it. Imagine a future where we have mastered these impossible movements. We could visit the gas giants of distant suns as easily as we now cross the Atlantic. We could witness the birth of stars and the dance of binary systems. We could look for life on the icy moons of Jupiter or the temperate planets of the TRAPPIST-1 system. The great silence, the haunting lack of contact from other civilizations, might finally be explained. Perhaps they are all around us, moving through the back doors of the universe, waiting for us to become sophisticated enough to see the shortcuts. We are living in an extraordinary moment. The first time in history, we have the tools to test the limits of reality. Whether this recent detection turns out to be a magnificent illusion or a fundamental breakthrough, it serves the same purpose. It makes us look up. It reminds us that we are part of something vast and ancient. The atoms in our bodies were forged in the hearts of stars that exploded billions of years ago. We are literally star stuff, and when we study the heavens, we are returning to our origins. So, let us wait for the data to be verified. Let us debate and calculate and dream. If the speed of light is indeed a wall, we will continue to honor it, finding beauty in the slow, patient crawl toward the future. But if that wall has a door, if the universe allows for movement beyond our current grasp, then the horizon of human potential has just moved out to the very edge of the infinite. We are a young species, barely a second old in the cosmic calendar. Our journey is just beginning, and the most exciting chapters are the ones we haven't yet learned how to read. The stars are calling to us, and they are not as far away as they used to be. How do you feel about the idea that our ultimate laws of physics might just be the first few pages of a much larger book?